Good morning, this is my tutor. Welcome to another edition of A for A levels. Today we're going to go through paper 1-3 of May-June 2020. Let's go. Find the set of values of m for which the line with equation y equals mx plus 1 and the curve with equation y equals 3x squared plus 2x plus 4 intersect at two distinct points. This is a question of intersecting lines. Equating y, you get 3x squared plus 2x plus 4 equals to mx plus 1. Writing it in the general form, you get 3x squared plus 2 minus mx plus 3. Notice that I write it in the general form. So if it intersect at two distinct points, then b squared minus 4ac is larger than 0. 2 minus m squared minus 4 times 3 larger than 0. 2 minus m squared larger than 36. Now in this instance, you don't have to expand and then factorize and find. You can immediately put like an equation. If it is larger, 2 minus m is smaller than square root of 36. You get minus 6, or 2 minus m larger than 6. So you have m larger than 8, or m smaller than minus 4. That's the answer. Let's go to the next question. The equation of a curve is such that dy dx equals to 3x to the power half minus 3x to the power minus half. It's given that a point 47 lies on the curve. Find the equation of the curve. You can say that this is a differential equation. So you need to integrate to find the curve. Integrate 3x to the power half minus 3x to the power minus half. Okay, so y equals to, you need to add the power by 1. Half plus 1 is 3 over 2 divided by the power. Same here. Minus half plus 1 is half over half plus c. Simplifying, you get y equals to 2x to the power 3 over 2 minus 6x to the power half c. So it passes through the point 47. Substitute x with 4 and y with 7. It's 4. 4. 6, 4, half. Okay, 7. 2 times 8, 16. Minus 6 times 2, 12 plus c. So c is 3. So the equation of the curve is y equals to 2x power 3 over 2 minus 6x to the power half plus 3. That's it. Next question. This is a question on transformation, graph transformation. In each part of A, B, and C, the graph shown with solid lines has equation y equals fx. The graph shown with broken lines is a transformation of y equals fx. State in terms of f the equation of the graph shown with broken lines. So this is a reflection on the y-axis. So y equals reflection on the y-axis, y equals to f of minus x. Okay. This is a vertical stretch invariant line. The x-axis and factor, scale factor 2. So this is y equals to 2fx. Now, this is a translation of 1, 2, 3, 4 minus 4 and 1, 2, 3 minus 3. So this is y equals to f x. If it's minus 4, you put plus 4, 3. That's it. Expand 1 plus a to the power 5 in ascending powers of a up to and including in the terms a cube. Okay, so this is quite a direct transformation. You can use the Pascal triangle, but I will just expand. 1 plus 5, 1a plus 5, 2a square plus 5, 3a cube equals to 1 plus 5a 10a squared plus 10a cube. That's it. Hence, expand 1 plus x squared in the ascending powers of x up to and including the term x cube. So in this instant, put a as x plus x squared. X plus x squared. So you have 1 plus x squared of 5. 1 plus 5 x plus x squared plus 10 x squared x plus x squared cube. Now they want it in terms of up to x squared. So I'm going to disregard the powers that are higher than x cube. 1 plus 5x squared plus 10 x squared plus 2x cubed plus x to the power 4. And now this is going to have x cubed. The rest has a higher power of x cubed. So I'm going to just simplify it. 1 plus 5x. 5 plus 10 is 15. X squared. 20 plus another 10 will be 30. X cubed. That's it. Now the next question is on circles. The diagram shows a cord going round a pulley and a pin. Pulley is modeled as circle with center O and radius 5. The thickness of the cord and the size of the pin P can be neglected. The pin is situated 13 cm vertically below points A, B on the circumference of the circle such that AP and BP are tangent circles. The cord passes over the major arc AB of the circle and under the pin such that the cord is taut. Calculate the length of the cord. Okay. Using Pythagoras theorem, AP and BP is the same length, would be 13 square minus 5 square, which would be 12. Okay. Angle AOP is equals to angle BOP. So finding one of them shall suffice. So you're going to use cosine. Cosine angle AOP, which is this angle, equals to 5 over 13. So angle AOP equals, I'm going to put the angles in radian. So it's 1.176. Okay. So angle AOB will be 2 times 1.176 would be 2.352. So major arc AOB r theta. Radius is 5 times 2 pi, sorry. 2.35 equal 19.66. 19.66. So that's string 2 times 12 plus 19.66. Going to be 3 significant figures. Would be 43.7. Okay, there we have it. Next, point P is moving along a curve in such a way that the x-coordinate of P is increasing at a constant rate of 2 units per minute. So this will be the x over dt. Equation of the curve is y equals to 5x minus 1 or half. Find the rate at which y coordinate is increasing when x equals to 1. So you are asked to find dy over dt, which will be equals to dy over dx times dx over dt. So this will be equals dy over dx will be differentiating, bring the power down, minus the power by 1, differentiate 5x minus 1 is 5, it's 2. Substituting x equals to 1, your dy over dt equals to 5 minus 1, power minus half. 5 over 2 units per second. Okay. Next, find the value x when the y coordinate is increasing at 5 over 8 units per minute. Sorry, this is not per second. This is per minute. So you're given dy over dt equals to 5 over 8. So using the same thing, 5 over 8 equals to half 5x minus 1 minus half times 2. So 1 over 5x minus 1 half equals to 1 over 8. So squaring both sides, you get 5x minus 1 equals 64. X equals to 13. Okay, that's it. That's the answer. Question 7. Show that tangent theta. This is proving. So you're going to prove from the left-hand side, which is more complicated. So what I'm going to do is, usually in this type of question, basically you don't have to. You make it into a single. So this will be tangent theta minus tangent theta cos theta plus tangent theta plus tangent theta cos theta. This is the reason why I don't change. So this will be 2 tangent theta, and expanding you get 1 minus cos square theta. Now you can change. 1 minus cos square theta is sine square theta. Changing tangent theta using the identity. So there you have it. It's 2 over sine theta cos theta. Sure. Then you're asked to solve the equation. So this is 2 over sine theta cos theta, and changing tangent theta to sine theta or cos theta, this one you get 6 cos theta over sine theta. By cross multiplying 6 sine theta cos square theta, using the identity cos square theta equals to sine square theta, you have 2 sine theta 6 sine theta 1 minus sine square theta. So you have expanding and moving all to one side of the equation. 6 sine cube theta minus 4 sine theta equals 0. Factorizing, you get 2 sine theta. Actually, you don't need to. Never mind, since I've done it. 3 sine square theta minus 4. Okay. Equals 0. So you have sine theta equals 0. Here you get no solution because sine theta is not 0 or 180. The other one is sine theta equals to 4 over 3. Let me check and see if it's correct. Okay. So sine theta equals to plus minus square root of 4 over 3. Theta equals to, now there are only 2 solutions between 0 and 180. So there's a problem here. There's no solution. I can even be tricked. Okay, let me check my answer. Oh, okay. I forgot to use this too. So sometimes you do a longer working. That is what happens. Okay. So the angle corresponding to the first quadrant is 54.7 degrees. The second quadrant is 180 minus 54.7 is 135.3 degrees. There, you have two solutions. Okay. Next, the first term of a progression is sine square theta, where theta is between 0 and half pi. Second term of the progression is sine square theta cos square theta. Given that the progression is geometric, find the sum to infinity. So A equals to sine square theta. The ratio will be the second term divided by the first term. Second term is square theta, so you can cancel. So it will be also sine square. Okay, mistake. Time's going too fast. Sine square theta cos square theta over sine square theta. It is cos square theta. Sum to infinity A over 1 minus R. So it will be sine square theta over 1 minus cos square theta, which will be sine square theta over cos square theta will be 1. So that's the solution. It is now given that instead that the progression is arithmetic. Find the common difference of the progression in terms of sine theta. So the difference is the second term, sine square theta cos square theta, minus the first term. Factorizing, cos square theta minus 1 is minus sine square theta. So it will be minus sine to the power 4 theta. Okay? That is the answer. Find the sum of the first 16 terms when theta is 1 over 3 pi. So I'm going to find the sum first. Sum of the S16 equals to 16 over 2 sine square theta plus 15 minus sine power 4 theta. So it will be 8 factorizing sine square theta 1 minus 15 sine square theta. Okay, so theta is 1 over 3 pi. So this will equal to 8. Sine of 1 3 pi is 3 over 2. 1 minus 15 root 3 over 2 square. Okay. So with 3 over 4, you can cancel, get 2. 1 minus 15 times 3 over 4 equal 6. 1 minus 45 over 4. 1 over 4. Minus 1, 2, 3 over 2. Okay, that's it. The function f and g are defined as follows. It must be important, we must see the domain. Express fx in the form x minus a squared plus b. So fx is 2 square minus 2 square plus 3. This is quite simple if you know how to do minus 1. Okay. It is given that f is a one-to-one function. State the smallest possible value of c. So this function will be minimum point to -1. So c will be equals to 2, which is the smallest value. It is given that c equals to 5. Find the expression and state the domain of the inverse function. So let y equals to x minus 2 square minus 1. So x will be plus minus square root of y plus 1 plus 2. So the inverse function, this is, you must be careful, huh? This is x larger, so it will be a positive value, huh? X equals square root of x plus 1 plus 2 as the range is larger than 2. Okay. So the domain x would be, wait, let me see, it's larger than -1. That's the domain of the function. So this is x larger or equal to, oh, no equal. Let me see what equal. There's no equal, so you be careful. Huh? Larger than -1. Find an expression of g of x and state the range of gf. Expression of g. What is g? 1 over x plus 1. Range of gf. C is equals to 5. Sorry, I'm getting this mistake already. This is wrong. Sometimes it works. You have to be careful. This c equals to 5. Huh? X is larger than 5. Okay. So your fx, smallest value of fx. So your domain will be larger than 5 minus 2 square minus 1, which is larger than 3 square minus 1 is 8. So that is the solution. Huh? X larger than 8. So the range of f is x larger than 8. X larger than 5. So what's the range of f? So this graph is like that. This is the asymptote. So it's x minus 2. So the graph will be, if it's x larger than 8, it is something like that. Huh? X larger than 5. So if it is 5, it's 5 minus 2 square. 5 minus 2 square is 9. So 1 over 9. It's 1 over 9. Hmm? 1 over 9. So the range, GF, is between 0 and 1 over 9. Okay. The coordinates of the 2 points A and B are -7, 3, and 5, 11 respectively. Show that the equation of the perpendicular bisector of AB is 3x plus 2y equals to what? Midpoint. -7 plus 5, 2 plus 2 equals to -1 and 7. Okay. Gradient AB. 11 minus 3 over 5 plus 7. So it's 8 over 12. 3. Gradient of the perpendicular is -3 over 2. So the equation y minus y1 equals to mx minus x1. So this y minus the midpoint is 7. Gradient is -3 over 2x minus 1 is +1. So this is y equals to -3 over 2x minus 3 over 2 plus 7. So plus 11 over 2. Okay, you have it. A circle passes through the points A, B, and its center lies on the line. Line 12x plus 5y equals to 70. Find an equation of the circle. So you have a circle A, B. Let's see what's the point. -7, 3, and 5, 11. It's good to see, to have a visual of your problem. Center. This center lies on this line. So you want to find the equation of AB. Equation of AB so that you can find AB. So just now we have the gradient of AB is 2 over 3. 2 over 3. Just now perpendicular bisector will pass through the center. So in order to find equation of circle, you must find point O, which is center, and the radius R. Okay, equation of AB is y minus 3 equals to 2 over 3x minus 7 is plus 7. 2 over 3x plus 14 over 3 plus 23 over 3. Okay, now substituting this into the equation. Oh, the center of the circle lie on this line. Sorry. So the center of the circle lie on this line. 12x minus 5y equals to 70. So you want to find the center of the circle. Okay, if you, this line has an equation which we have found. Oops. This perpendicular bisector also passes through the center, which is y equals to minus 3 over 2x plus 11 over 2. Y equals to minus 3 over 2x plus 11 over 2. Okay, so we need to solve these two equations to find the center of the circle. So substituting y, 12x minus 5 minus 3 over 2x plus 11 over 2 equals to 70. 12x plus 15 over 2x minus 55 over 2 equals 70. I'm going to multiply all by 2 now, becomes easier. 24x plus 15x minus 55 plus 140. So here we have 39x equals this equal 195 x equals to 5. Okay. For y, so substituting 12 times 5 minus 5y equals to 70. 5y equals 60 minus 70 is minus 10. Y equals to minus 2. There you have it. The center of the circle O is minus 2. The next step is just to find the radius. So the radius will be the length of OB or OA. So it will be using the formula. Oops. 5 minus 5 plus 11 minus 2 plus 2 squared. So you find it is 13. So the equation of the circle is x minus 5 square plus y plus 2 square. Okay, we have it. Next question. That was pretty tricky. The diagram shows part of a curve with equation y equals x cubed minus 2bx squared plus b squared x and the line OA, where A is the maximum point on the curve. The x coordinate of A is A, and the curve has a minimum point at BO. Where A and B are positive, show that B equals to 3A. Well, maybe you want to find different shade and see dy dx. 3x squared minus 4bx plus b squared. Now at the maximum, minimum, it will be 0. Okay. So since A is the coordinate, x coordinate of the maximum point, it should solve this equation. So 3a squared minus 4ab plus b squared equals to 0. X is equals to A. Now you factorize, I believe you can factorize 3a, A. So this b minus b minus b. Okay, so here you have it. It's either A equals B, which is the minimum point here, or 3A equals to B, which is the maximum point. show that the area of the shaded region between the line and the curve is Ka squared, where K is a fraction to be found. So the area of the shaded region, area is equals to 0a. Equation of the curve, y equals to x cubed. I'm going to substitute b with 3a, minus 6ax squared is b square x. B square is 9a square. 9a square x. Minus the line OA would have the equation. Okay. I'm going to find what is the point of y. A cubed minus 2ba squared plus b squared a. A cubed minus b is 3a, so 6a cubed plus 9a cubed equals 4a cubed. So the line OA is equals to, is y equals to, the gradient will be 4a cubed over a. So it's 4a squared x. Okay. Okay. So I'm going to simplify first before I integrate. This is the equation of line OA. X cubed minus 6ax squared plus 5a squared x dx. X to the power 4 over 4 minus 2ax cubed plus 5a squared x squared over 2 a0. Substitute a. So a to the power 4 is correct. A to the power 4 over 4 minus 2a to the power 4 plus 5a to the power 4 over 2. So this half plus a quarter is 3/4. Okay, so therefore K is 4. That's the fraction that they are looking for. That's it. Like and subscribe, please, if you want more of A for A levels. If you want this paper, you can put in a comment. I will email it to you. Bye for now.